Hello everyone, I am Arnab Kumar Roy. I am a student of American International University, Bangladesh. Today I am presenting our project that's named Logic Based Password Protection System, and that is supervised by our Honorable Teacher Nafiz Ahmed Sisti sir. So, so we are two members in our group. So that's me, and other member is Farad Hussain. So let's start it our presentation. That's introduction. In our increasingly digital world, the need for secure access of a person and sensitive information is undeniable. So many system and device require password-based authentication. So grant access from smartphones to bank ATMs and other systems. So ensure that only authorized individual can gain entry is a crucial concern. So traditionally password protection system really on software-based solution often integrated into the operation system application. That system can be vulnerable to various threats including hacking, malware or software vulnerabilities. As a result, there is a growing interest in exploring hardware-based protection systems that can provide an additional layer of security. So the project delves into the realm of hardware-based protection, password protection. So, especially focusing on using digital logic circuit and components to create a robust of reliable system. By shifting the security focus from software to hardware, we aim to explore a novel approach to password protection that can resist common software-based attack. So, our projects have some objectives. So, develop hardware-based password protection, create a password protection system using digital logic circuit, enhance security, extend security by mitigating software-based vulnerabilities, integrated digital logic principles, demonstrated principles, practice application, showcase real-world cybersecurity solution that logic concepts. So, the methodology and modeling of a project. This section provides an overview of a methodology and modeling techniques employed in the development and implementation of the logic-based password authentication. So, system described in this project, it outlines the systematic approach used to design, simulate, and construct the system, emphasizing the logical components and their interactions. So, our main theme of our project is working principle of the purpose project, that user input and initialization, password compromission using digital logic, and bitwise compromission and digital logic decision making, and authentication outcome, hardware level security, redundancy, and error detection. So the user input initialization is the user enters a password through an input interface such as DIP switch. During the initialization phase, the correct password is stored in a system by another DIP switch, which is acting like a memory. So password compromising using digital logic. The entered password is in binary form, consisting of a sequence of ones and zeros. Digital logic gates and circuits are utilized to compare each bit of the entered password with the corresponding bit of stored password. So that's why we set a password for the user, and it's like a memory. So bitwise compromission is the bitwise compromission is digital logic circuit, that is the bitwise compromission result determine if is bit of the inter password match. That's called when we input a or set a password, and then we compare the inter password, so that the decision logic evaluates the overall compromission. So the bit is, if the bit is the bit is the active stored bit, and the inter bit is equal when the password is correct. That's mean then the machine is running. So if the password is wrong, not matched with the bit stored bit, that's called wrong password. So authentication outcome. If all bits of inter password match corresponding bits are stored password, the system grants authentication. If the password is correct, the system grants you to authentication and access. So if the bit does not match, so the system denies access. So hardware level security. The security system strength lies in its hardware-based implementation using digital logic circuits. Hardware level security provides resistance against certain software-based attacks and vulnerabilities. So redundancy and error detection. Redundancy can be implemented using parity or error checking bits to enhance security and detect potential error in the inter password. So at last we can say that alarm and use of JK flip-flop. Using JK flip-flop in digital security system is a common practice for our counting incorrect password system. So attempts and enhancing security, is incorrect attempts trigger the JK flip-flop to increment the count. So when this count reaches a predefined limit, we defined a limit that is typically 3. So it triggered an alarm or security response, discouraging the unauthorized access. Resetting the count 0 occurs upon entering the correct password, preventing continuous counting. So the approach adds an effective layer of security, so that we can understand anyone or any person can, if they input a incorrect password, then we can access that the person is not our in our project. So the by limiting password guessing and ensures a mean of authorized user to reset the system after an alarm is triggered. Flexibility and customization. The system can be designed to accommodate password and varying length and complex requirement. Digital logic circuit allows for flexibility in handling defined input systems. So real-time processing. The authentication process occurs in real time, allowing for quick access decision based on the confirmation result. So there are many components in our project, that's jumper wire, DIP switch, breadboard, resistors, jumper wires, buzzer, 4 input AND gate, XNOR gate, a capacitor. Description of components. So the components like 555 timer IC that integrated an circuit used to generate accurate timing pulse in various electronic applications. At JK flip-flop, LED 2 input AND gate, NOT gate, push button switch, power source, 5 volt. So the JK flip-flop is a sequential logic circuit that can store and toggle binary information, often used in memory elements used in the project to keep track of the incorrect and correct password. So simulation setup. So functional variation. So inputting the correct password was validated to confirm that system granted access and provide positive feedback. The system's behavior was tested by various password lengths and combination to access its robustness. Timing accuracy of the 555 timer IC was measured using an oscilloscope or a timing diagram. So the main theme of our project is the simulation and the circuit diagram. So now I am discussing about the simulation. The simulation is like, we can see that we set a password. We set a password for a, that is 5 push button. We can see that the set password, we set a password that is 10101. Now when we check a password, the initial condition, when we start, that initial condition is like check password is 0, but when we started, then the initial password that space is 1, that count 1. So when we enter a password, when we first time enter a correct password, we can see the green light is 1, but when we input a wrong password, then the red LED is on. But when we enter a wrong password 1 time, 2 time, that's 1 time wrong password, and that is show that 2 time wrong password, and finally when we enter 3 time password, then the buzzer is on, because when the JK flip-flop count 3 time, we initially set that time, that 3 time, after 3 time counts, the buzzer is on, and this buzzer connected light red LED also be open. And then the counter, the JK flip flop, then the JK flip flop will reset. Then after 3 times wrong password, the JK flip flop will again count 0 1 2. So after 3 times it's again repeat and reset. So and that's time the display count 0 1 2. The other part of our project will discuss our next member.
Limitation of the project. Limited complexity. The project hardware-based approach may impose constraints on the complexity of the authentication process and security features due to the available digital logic components. Fixed password length. The system design might necessitate a fixed password length, potentially limiting flexible in user-defined password length. Hardware constraints. The circuit complexity might be constrained by available components, affecting the ability to implement advanced security measures. Susceptibility to physical attack. Hardware-based system may still be susceptible to physical attacks such as reverse engineering or component manipulation. Learning curve. Understanding digital logic design and circuit building may pose a learning curve, especially for those new electrons. Limited feedback. The system feedback mechanism (LDS) and buzzard might provide limited information, making it changing